What is the function of a diode and its uses?
Diode is one of the types of semiconductor parts that are used in many electronic circuits, and it conducts the electric current in one direction and prevents the current from passing through the circuit in the opposite direction. In fact, a diode is a two-terminal solenoid valve that moves current in one direction. These parts are made of various semiconductor materials such as silicon or germanium. They are formed by connecting two impurity regions P and N. For a better understanding diode, we need to know how P-N junctions work in semiconductors.
The internal structure of the diode. P-N junctions in semiconductors are created by a process called doping.
Investigating the topic of making P-N junctions is very specialized and is far from the topic of this video. But in short, it can be said that in this process, impurities of N and P type are placed on the sides of the junction and create empty holes and free electrons. These holes and free electrons at the junction of two areas N and P are attracted to each other and form a special region that has a completely neutral electric charge. This neutral region in P-N junctions is called the depletion region. The existence of this area with a certain width is the main reason for current passing through one side and not passing through the other side of the diode.
To create the P region, gallium, aluminium, and boron, impurities can be added to the semiconductor material. Due to the addition of these materials, a large number of holes are created in this region. The P region in a diode is known as the anode, and it forms its positive pole. Impurities such as phosphorus, antimony, and arsenic are used for the N region, which increases the number of electrons in this region. Therefore, each type of diode, regardless of its special features, has two bases called anode and cathode. According to the different load on the two bases of the diodes, two types of bias can be considered for them, which we will introduce. One. Forward bias.
In the equilibrium state of this device, there are no electrons between the anode and cathode regions until a forward bias voltage is applied to it and current flows through it. Direct bias means the situation where the positive end of the diode, anode, is connected to the positive end of the power source and its negative end, cathode, is connected to the negative end of the power source. The level of discharge is greatly reduced and the base electrons of the anode move easily to the holes of the base of the cathode and the diode passes the current, and as you can see, the circuit is completely established.
Two. Reverse bias. If we reverse the direction of the supplely applied to the diode and connect the positive terminal of the power supply to the N region and its negative terminal to the P region, it causes the holes to retreat to the other side of the connection and the electrons. It will move in the opposite direction. This happens, very little current flows through the PN junction and the width of the discharge region becomes much larger. As this area becomes wider, it becomes harder for the current to pass, and in fact the diode does not allow current to pass through itself, which leads to this. This is called reversal bias. In this case, the circuit is not established. The use of diodes in reverse bias may cause the breakdown of the drain region and the so-called burning of the diode. Special diodes such as Zener or Avalanche can take the direction of the reverse current and be used in this situation. Diode circuit symbol.
In most diodes, there is a gray band at one end of the piece that indicates the direction of the cathode. Its circuit symbol is a triangle that points to the cathode and a line is perpendicular to its tip. This symbol indicates that the conventional current in the circuit. It is directed from the anode side to the cathode side. We know that in practice, the electrons of the circuit move from the negative side to the positive side, but by convention, the direction of current flow is against the movement of electrons.
How does a diode work?
The function of these parts in a nutshell is that they pass electric current in forward bias and act like an open switch in reverse bias. The voltage current diagram means that in the case of forward bias, as the voltage increases, the amount of current through the diode increases almost linearly. It is like an open circuit. According to the structure of the semiconductors inside, each diode has the ability to withstand reverse bias up to a certain voltage, which is called the breakdown voltage, VBR.
To support me, subscribe to my channel. Like my videos. Press the bell button for notifications. Subscribe to my channel for new videos. Share my videos. Write me a comment. Thank you.